sir.
All righty. Good afternoon, everyone. Thank you for joining us today and your interest in water loss and water auditing. For those of you who don't know me, my name is Steve Marsh. I am the Water Service Specialist for IAMU. Prior to my employment here, I was an operator for the city of Pleasantville. And just one of the few things that would keep me up at night was water loss. Always bugged me, why don't the numbers add up? We haven't had a spike in usage, but do we have leaks? Should we be replacing meters, or where do we even start? Joining us today is Steve Cavanaugh and Will Jernigan of Cavanaugh Solutions. Both are members of the AWWA Water Loss Committee and are leaders in the field in water loss, auditing, and capturing non-revenue water. We kicked this off with a 3-hour pre-conference workshop back in November at our Water Wastewater Operator Conference, in which some of you attended. After we got a lot of positive feedback from that, we decided to take the next step and to have this webcast to hopefully gain more interest in this and go after some funding to provide a technical assistance program. Correct me wrong, Steve and Will, but I think we have 33 states that have moved away from the traditional percentage water loss way of thinking and now are using the AWWA M36 water audit methodology. Is that correct?
Hey, this is Steve Cavanaugh. Yes, that is correct. They're in the process of moving away from percent unaccounted for water reporting at various stages. They're learning, they're performing pilots, they're reviewing their current regulations, et cetera. But actually 33, maybe 34 now are in discussions.
Yeah. So this is the way things are moving, and we'd like to jump on board. At least I would here in Iowa, and continue with the way things are going with the rest of the country. So I think that's all I have for an introduction to get started. With that, I'll turn it over to Steve and Will.
Sounds great. Thanks, Steve Marsh, for the intro comment. This is Will Jernigan with Cavanaugh, and very glad to be with you today. I'm going to be carrying us through a lot of the content today. We're talking about water loss and non-revenue water. We'll be looking at why it's a relevant issue. We'll be looking at some of the complexities of the issue itself. We'll be looking at how different utilities are approaching it and tackling it. Central to our discussion today will be the AWWA method for tackling this issue. It's known as the M36 method, refers to the M36 manual. So that'll show up a few times as we're having our discussion today. But again, very excited to be with you. And I think we're in just a couple program notes. We're going to have the lines muted, and we will have an opportunity to do some Q&A at the end of the webcast. So if you do have questions, two things you can do. One, you can type the question into the question box on your screen, or you can just jot it down, and when we get to the end, we will unmute the lines and hopefully navigate the audio of several phone lines dialed in, etc. But we'll have a chance to do some Q&A at the end. So very good. With that, let's go ahead and get launched right in. And I want to start with what makes this issue relevant. And the answer might be different depending on where you're coming from or what your particular utility situation is. It could depend on where you live in the country as well, but even within the same state or region, there are different drivers. For some folks, drought and extended strain on supply is something that makes this particular issue relevant. In other cases, it's more of some political attention or maybe media attention that's been drawn to the issue, or maybe it comes up at a council meeting or something along the lines of questioning how, quote unquote, I'm here, air quotes, how efficiently the system is being run. Some of these, unfortunately, are misguided media stories in many cases. Nonetheless, it's a perception you have to deal with. even if that perception isn't true, if the ratepayers and the consumers perceive that the system is not being operated as efficiently as it could be, that can create issues and angst with the ratepayers and the customer relations. So bring that up because sometimes that makes how water loss and non-revenue water are managed, it makes that very relevant. And there are some good examples of utilities that have really taken this by the horns and turned it around and put a water loss program in place, and it becomes very positive PR messaging. So some folks, that's the driver. Other drivers that we've encountered, the bond rating agencies are starting to look more closely at this. That's something that's fairly new, looking specifically at what practices are being employed, all the way from just the auditing piece of it to conducting interventions such as leak detection. And we'll get to in just a bit the notion that leak detection is not the only tool in the toolbox, because there are a lot of other things that are happening in other ways that need to be tackled. But anyway, those bond and rating agencies are taking more of a closer look at that and credit worthiness. Probably have seen this cartoon before, but from a supply standpoint, if a utility is looking for expansion of existing supply, water loss is actually the closest and cheapest thing that can be tackled first. It doesn't mean you avoid having to, per se, expand that plant or drill that new well or make that additional intertie if you're a purchase system or whatever the case may be. But it certainly is, there's a relationship between how much of the water you're currently bringing in turns into water loss and how much additional capacity you need, and even offsetting the time, how soon that expansion may have to occur. A good example of that, just here in our setting the stage discussion, in the city of Asheville, in North Carolina, happens to be my hometown, so I'm proud and want to use this one as an interesting example. They've been working on reducing water loss for about, I would say, 10 years concertedly. And they've had capital projects, but also an ongoing water loss program. And over that 10-year period, from 2008 till today, their cumulative water savings, or avoided water that they're not having to withdraw from the source, is around 6 billion gallons. For them, that's about a year's worth of supply. And so that's a positive from a supply standpoint. They've also been able to translate that into, because we weren't extracting that water from the source, that means we weren't having to pay electricity to pump it. That means we weren't having to pay for chemicals for treatment. And we have other costs associated with production and delivery. And cumulatively for them, it's been about $3 million in, I'll call it avoided costs. That's money they're not spending on the production and delivery of that water because they've been able to reduce water loss. So that's a big deal. It's also another positive PR that they've been able to take and say, okay, look, we've had to have rate increases over this 10-year period. Every system has to have rate increases. Costs up, you have to stay with that. But this has been able to offset what those rate increases otherwise would have been, and so it's actually a win for both the utility and the ratepayer. So those are some, I would say, big picture drivers. In reality, most utilities we work with and encounter, it's some combination of all of those things or some of those things. It's not always just really one driver, but I wanted to start with that so that the folks on this webcast can reflect maybe what among those drivers makes this issue the most relevant for you. Where is your interest coming from? Why did you come today? And those types of things. So be thinking about that, and that may help stimulate some questions in your mind that we can hit when we get to the Q&A. This is the big picture, and when we speak of the best practice method for understanding what your losses are, and then being effective and most importantly cost effective at addressing them, reducing them to an optimal and cost effective point. This big picture helps us understand what that M36 methodology really is. It starts with baseline, conducting an annual audit, and we'll talk a little bit about the nuts and bolts on it today, just to give everybody, if you're not already familiar with the AWWA water audit, to give you a feel for what that looks like and what's involved. But once you get that baseline, we have a high-level understanding of what losses we're experiencing. There's some additional technical understanding that you really need before you know what tool to pull out of the toolbox to address a particular part of the problem, because it's not all leakage. And there are other things at play, and in particular, it's not even all leakage that can be recovered through traditional means. So the economics of it, that's the third step in this four-step graphic. We want to consider the dollars because we want to make sure we're not overspending to address it. You can't be cost effective if you don't kind of know what the cost versus the benefit relationship is. So we'll come back to this big picture arc, but I wanted to show it now because it is a theme that will occur as we're talking through. This practice is well established. This best practice is well established. The first version of the M36 manual came out in '91, and it's now in its fourth edition out just a couple years ago. But it's a capture of really the best practices for everything from conducting the audit, really all those big picture steps I just showed, developing the audit, breaking the technical parts down, looking at the dollars, and then saying, okay, based on that, here are the cost-effective steps we want to take. Here are the right tools to apply. So that's the M36 methodology. It's captured in there. About 10 years ago, the AWWA Water Loss Control Committee came out with the first version of the free water audit software. It's meant to be a companion tool, but it's freely available from AWWA. It's Excel format based, and it's intended to be a standardized format to conduct the top-down water audit. And that standardized format gets to essentially what's known as a water balance. And for those of you, I imagine some may be familiar with this concept and may have seen this before. It looks at system input and assesses the potential that there sometimes can be known error in those numbers as well. If we're relying on system input meters, those can have error for a number of reasons, and we want to be able to understand it, quantify it, and account for it. But from there, water loss breaks down into consumption, or excuse me, system input breaks down into consumption or loss. It's one of those two. The further breakdown gets into these terms apparent and real, and we're not going to dive really, really deep on this today, but just to hit enough depth that we establish that loss occurs either as physical leakage, which is known as real loss, or it occurs as not physical loss, but revenue losses. And those can happen through either a meter is not registering everything that's passing through it to the customer, unauthorized consumption, which would be when you have theft occur. And there is another category that relates to the data handling, and that's in the metering and billing systems. There are some things that can happen that can ultimately cheat you out of the revenue that you're due, and it really deals a lot with the data management. So we won't dive too deep into it on today's webcast, but I want to set the stage that loss itself is a complex issue because leakage and apparent losses break down into these multiple categories, and if you're setting out to address them and try to reduce these different things, well, one tool will work for one piece of it, but it won't work for another. So you have to have a good understanding of what that profile looks like. You'll notice this term non-revenue water, and I want to take a moment and just distinguish. Water loss is part of non-revenue water. Non-revenue water, as you can imagine, is water that's delivered into the system but just for any reason doesn't bring revenue back to you. If you lose water, certainly you're not getting revenue from that, but there's also these unbilled categories that are authorized but unbilled, such as firefighting or perhaps the municipal connections or government buildings and things like that. Every system has it, but it is part of the non-revenue water profile, so that's part of the water balance, is understanding how that fits in. Maybe it's a lot, maybe it's not much, but we want to make sure we're properly accounting for that so we don't mistakenly think that those flushing volumes or those firefighting volumes, as an example, are showing up as losses. We want to make sure we're chasing the right thing. So that's a quick look at the water balance. The output of the water audit, once the inputs are developed, performance indicators are what come out of the audit. And in general terms, we think of those in terms of the 3 V's. Validity is generally how reliable are the numbers coming out of the audit. And then from there, volumes and values essentially hit the key questions of how much loss is occurring for those given types? And then most importantly, what is it costing me? Because that's going to set the stage on what would be appropriate to then pursue it and be cost effective at intervention. So those are the 3 V's. Again, these are themes that we'll come back to, but we look at those in terms of volumes and values ultimately, but we have to consider the validity first, because the validity sets the context for how reliable those volumes and values are. Just a quick note on looking at water loss in terms of percentage. This is something that's common, and I think Steve alluded to it at the opening comments. A lot of state regs have this percentage metric there, and so it's a part of history, if you will. But it's a challenging metric. This is just a fun example. This is a real-world example where a utility was tracking 6 or 7 of their wholesale customers over a number of years on the percentage of water loss, and they saw a wide variability. It was really high, really low, year to year, and that's the inherent challenge of the percentage metric. Is it's highly sensitive to changes in demand. So if you sell a bit more water next year, that's going to affect your percentage, even though your water loss may not have changed. Now the metric has moved, and you really don't know if it moved because you did better or worse with your loss, or simply you sold more or less water. It's highly sensitive to those changes in demand, which make changes in supply, and that changes the bottom of the fraction for the percentage. So real tricky there. Just to round out that illustration, this is a real world example as well from the city of Philadelphia. They actually made significant strides in reducing their loss. Total non-revenue water actually reduced from almost 120 million gallons a day down to around 70. So pretty substantial reduction over the 25 or so years that they've had an active program. But because their customer consumption was also decreasing during that same period, and that is what was happening there, the system was, or the customers were being more efficient. This is the 90s, right? So the toilets got more efficient, fixtures got more efficient, customer behaviors probably got more efficient as rates went up. All of those things resulted in conservation. And if you look at the red line, their percentage of non-revenue water stayed around 35% immediately over this 25-year period, simply because while they were improving their loss numbers, at the same time their customers and their overall demand was going down. So the metric doesn't really, it's problematic because it doesn't really indicate what's truly going on. And that's why we want to focus on the volumes and values of loss and use those as our guide, ultimately with the validity and making sure that we have a good feel for how reliable are the numbers. So with that, I'm going to turn to back kind of to the big picture, and then we'll look at a little bit about what's happening across the country on this topic. But the ultimate goal when we're saying to target reduction of loss is not to get it to zero. That's not something that's technically possible or financially feasible, cost justified, if you will. But there is an optimal point where, as you reduce, you're going to get to a point of diminishing returns where if you continue to pursue, then you'll end up spending more than it's worth to recover. And so that optimal balance is really that cost-benefit balance is what the M36 method is seeking to identify, to get to, and from there to maintain. And that's the overall idea. Even if you're not doing anything today and you have what we might consider the reactive program, you replace the meters as they die, you repair the leaks as they surface, there's a cost associated with that. Even though your proactive intervening cost is low, the cost of the loss itself, especially when you consider those meter and billing related losses, because those aren't hitting you at just wholesale costs. Those are hitting, that's revenue that you're missing. So they're hitting you at the revenue level, and they're very, very expensive. And so the do nothing or the reactive approach rarely is that the most cost effective approach. And there's always money left on the table. So that's the general idea with what the M36 program is targeting. Across the country, as Steve Marsh mentioned, several states are evaluating what their current policies for reporting, and even those that have performance targets where you have to meet a certain level. There's a lot of reevaluation of that going on because a lot of folks are stuck back into the percentage of loss or even percentage of unaccounted for water, which is much more the historic way that it's been looked at, but not the way that's ingrained in the M36 methodology. Some states have gone all the way to require the AWWA software and the AWWA method, along with what's known as the validation review, or a high level or level 1 validation review. We'll talk just a little bit about that as it relates to the potential for a technical assistance program in Iowa as we get here in just a bit. But that's the lay of the land, and as Steve Cavanaugh mentioned, this is something that's almost changes every few months. We kind of have to go back and make sure our map is updating the pace at which this particular issue is being looked at and updated at the state level. A lot of what's driving that is uncertainty in the numbers, and I wanted to talk a little bit about some of the things that are naturally there, inherent in our systems, that can create uncertainty, that can create error. And I like to start with consideration of this question: why wouldn't my numbers be right to begin with? Why wouldn't I go to my SCADA, hit a button, get my supply volumes, go to my billing system, hit a button, get my numbers, and everything shakes out the way it needs to? Well, what we find, and this is actually something that's been interestingly borne out in a research project a couple years ago, looking at thousands of audits around the country, is that there are some inherent and embedded things that can happen in our supply systems and our billing systems that on their own they're working fine and for their intended purpose. But when you take these numbers and put them all together in a water balance, there's some interesting things that can happen. Here is a fun example of a supply meter based on water coming from the well, and a fairly new meter, checked out fine from the manufacturer, and the meter itself is great, proven to be doing well. When it was installed, it was installed in proxy to this check valve, and the location of that check valve caused some funny things to happen hydraulically that caused the speed of the water at the bottom of the column to be the fastest, where typically it's in the middle of the water column, and that's the way the meter is designed. It caused the turbine mechanism to overspeed, and the numbers weren't quite looking right, so they had an on-site test done in situ, and that test revealed that meter was actually over-registering by quite a bit. And this was an interesting, this is an interesting example. Unfortunately, it's not too uncommon to run into these types of things, because the sighting of the meter, historically, and those types of decisions made a long time ago, it isn't always in the best interest of what's good for that meter and to read in an ideal condition. A lot of times it's just you've got so much space in the well house, and that's where the meter's got to go. So this type of issue creates error. Notice this isn't the operator doing the math wrong. This isn't a human error. This is something that's embedded into the system, and the numbers that are being produced from the get-go have this embedded error in them. So location of supply meter, hopefully those of you listening to the webcast, you maybe some of you have run into this, and this is something that's relatable in the location of your supply meters or situations that you've encountered. Another one that we commonly run into, when those supply meters generate the flow, and then if you have a SCADA system that those numbers go to get archived, if there's ever an instance where the communication between the meter and the SCADA get interrupted for any period of time, it creates what's known as a data gap or a period. And you can see this illustration. Again, these are real world illustrations. I think this one's from Philadelphia as well, where from 4 to 10 o'clock, there was an interruption in the comm, probably a lightning strike or something, maybe a storm. And as far as the pump knew, everything's churning like it should be. But as far as SCADA was concerned, there was no water produced between 4 and 10. And that's what got archived into the history and the archives within the SCADA. So you can see just these two numbers side by side. That can have a detrimental effect on the accuracy of that totalized volume. And if you're sitting down to do your water audit, you go to the SCADA system and again press the button, and it's exporting these numbers, and you get the 151 instead of the 212. You're dealing with bad information to begin with. And again, this isn't human error. These are things that can inherently happen within the systems. That last example I mentioned about the meter being too close to the check valve, that was one of many tests that were conducted in the state of Georgia. They did some state-funded assistance, and what they found was a high rate of failure of those meter setups, almost half, and then another third were not testable because the plumbing was so tight there was no place to get on to conduct a secondary meter and conduct a test. So this is super problematic in how wide and extensive these types of issues can be. So that's a big deal. Just quickly on the billing side, all sorts of issues that can occur similarly when things go to get archived into the billing system. Sometimes they're true issues and they're there. Whereas, let's say there was a customer side leak, so there was an abnormally high volume for that month, and that was a real amount of water that passed through the meter. But in other cases, it's just an erroneous reading that maybe got fixed for the billing purposes, but then when it got archived in the billing system, it's this crazy number that's super high, and it needed to be corrected. The archive actually preserves the erroneous number rather than the good number. And these are issues when you go sit down to do the water audit and say, okay, I need 12 months worth of what we sold last year, and you hit the button. Sometimes it's pulling from this information that inherently the raw data has these bugs and these gremlins in there. So these are systematic things that are really far more common than we'd like to see. And so that's where the step of validation and that a little bit deeper technical understanding, not just the baseline where we go and hit the button and we get those summary volumes. We got to look under the hood. We need to know where those numbers are coming from, and that's part of the M36 process and part of that natural process of getting good comfort level on how valid these numbers are that we're dealing with. Just a couple more pieces to round out, and then we'll make sure we have enough time today for our Q&A. The big picture. This is back to my hometown of Asheville, North Carolina. I mentioned they've been at it for about 10 years, and they've got a really neat story to tell. Their water loss has actually shown pretty steady reduction. You know, you can see these dotted lines in the background. That's the variable month-to-month data that's always going to move around. As long as your supply meter readings are not exactly the same timing as your customer meter readings, you're always going to see that. But on a rolling average, which normalizes that out, they've seen significant reductions in their loss. And what's happened is the green line through that same time period, they have sustained growth through the beer industry and tourism and new businesses and other industry. So they basically sustained that growth, and their rolling average of how much water they're extracting and therefore the associated cost to produce the water and supply it for the system is stayed about the same. So they have essentially sustained 10 years of growth through tightening up the system and making it more efficient. So from a supply standpoint, this is a big deal. From a cost standpoint, this is a big deal. And from a resource stewardship perspective, this is a big deal and something that's been very important for them. And again, thinking back to that driver of what makes it important for you. So with that, I'm going to round out our presentation with just a little bit of what the state of Iowa is, or what Steve and the association is looking to do in the state of Iowa, potentially for a technical assistance program. Again, it's all in the early discussions phase at this point, but I wanted to give a lay of the land for what that kind of program can look like and does look like in other states. Several other states have taken this initiative to establish some just at a small pilot scale, some at a medium scale, in some cases full statewide scale, where they're looking to bring the M36 method training and technical assistance on that to the utilities within the state. What does a typical program look like? Well, usually begins with a webinar that's fairly brief, but introduces, as an example today, we've introduced very briefly the water balance concept, terms like leakage, which is real loss, but other terms like apparent loss, which deal with metering and billing and theft. So a kickoff webinar would dive a bit deeper into that and establish more of a technical foundation of what are those terms and concepts that are central to the method. From there, there's a period of gathering data for the participating utilities. And that gathering of data, I'll actually show a quick list of that in a moment. That gathering of data would be used to help build the baseline audit, or I'll call it the practice audit, to put together as a go-by. And then there's a convening of the utility and the teaching team to then have time together working with that data, walking through that process of building the audit, the validation step, that initial level 1 validation step. And all of that is built around the utilities data and the utilities scenario situation. So this is different from, say, if you went to a class or any type of workshop and it was some concepts and some general teaching, but I mean, it's not really about your data or your situation. This is very much intended and designed around that. The outcomes of that is also utility specific. I'll hit that in just a moment. Typical data that's involved when you're looking to develop a baseline audit. I'll start by saying the data that you generally need is largely the data that you're already tracking. It's just a matter of putting your hands on it and maybe organizing it just a bit. But you got to start with supply numbers. If you're producing your own, if you're purchasing, if you are doing any testing or calibration of supply meters, that becomes relevant. On the consumption side, tracking water that's billed to customers, any unbilled water, flushing volumes, if those are tracked, general billing data, meter data, and these are all, some of these things are essential, some of these things are helpful if you have them, and so that's usually the approach in this is it's really the things that are largely at your fingertips. Some basic system data and cost data become important when you are looking to translate that water balance into some performance metrics and look at how those performance metrics maybe stack up your utility if you wanted to compare to another utility or to some benchmarks of any type. These system and cost data help to do that. Ultimately, you also have to have your cost data to assess the total cost impacts to you from both the leakage and the apparent loss types. So all of this fits neatly on one audit worksheet, so really a very manageable total number of data points and pieces of information when you get into it. Who typically is involved when it comes to preparing a baseline audit and participating in a typical program like this? Well, here's a fun graphic. This is actually a live shot from a program in another state, and the usual suspects are folks from operations, folks from metering, folks from billing. Those are sort of the three, I would say, core areas that really need to be at the table. But I would not leave out management, and in this case, you see the example of the general manager. But the management representation there is super critical, because once you do an audit and you figure out what's going on and what next steps you need to take, if there's not buy-in and institutional support at the utility, then it doesn't tend to go very far. And so management is a key role and a key player out of this. It's real interesting, the dynamic that can occur here in a good way, because when you start to put these audits together, it almost compels or requires that there be communication between departments, which there aren't a whole lot of other things that compel that or that naturally require. Different departments in the water utility are doing their thing, everybody's humming along and fairly focused on their part of the utility. But when it comes to the water balance, it requires information from all of those different departments. So that coordination really comes out of that in a good way and fosters communication and, I would say, cohesion between the departments. So very, very neat. Fun fact, this guy right here was in the witness protection program. So if you see him around, don't mention that you saw him on this webcast. Typical program outcomes for, and this is normal again, these just sharing some experience from other states, not quite at the point saying exactly what's going to happen with the association with Iowa. But typical program outcomes from other states the top-down audit, that baseline audit with level 1 validation, and then using that to identify specific for the utility, what are the next steps to focus on for water loss and revenue recovery. Sometimes those next steps can be focused on a deeper technical understanding. Sometimes it's more on the economics piece. Sometimes the data is rock solid and you're ready to really get on and get deeper into this 4-part overall methodology. Sometimes you get to the end of the audit, this first baseline audit, and we assess the validity, and it just says, hey, these numbers aren't reliable enough yet. We've got to focus on really tightening up where those weak points are in the data. Think back to that example where the meter was too close to the check valve and producing supply numbers that were 40% too large, over registering 40%. So that would be a perfect example of, hey, there's a lot of uncertainty around the supply volume here. That really needs to get solved before we really have a good understanding of how much loss is really happening and what is it really costing us. So we don't want to jump to here and say, gosh, let's go do a bunch of leak detection, let's go replace a bunch of meters, or whatever the case may be, before we have that solid understanding of the validity, how reliable it is for us to look at. So with that sort of brings us to the presentation of the M36 concept and how it fits together from an audit to the technical relationship and the technical profile of the different types of loss, what it's costing us, and how that cost compares to what it might cost to do something about it, and then ultimately using that knowledge to say, all right, here are the right interventions at the right level, and this is what makes sense for my utility. With that, I'm going to pause and actually ask Steve Marsh if you had any comments at the tail end of my presentation here specific to anything maybe that I've shared, and then after that we'll go to Steve Cavanaugh to facilitate our Q&A.
Thanks, Will. I don't really have anything right off the top of my head that you didn't touch on. Like you said, you didn't get dive real deep into it, just kind of an overview. And a lot of the stuff that I think we're all doing, but it just validates those numbers, I think is the biggest thing that I can think of where this helps out. And then the intervention part of it, where to start, where to go look, and is it cost effective enough to do it? So those are the things that I can see really benefiting folks out there. So
sure.
I'll turn it over to Steve then.
Thank you, Steve, and good job, Will. Just a couple of high-level things I'd love to add to this also, and basically to say, Steve Marsh, when you took the time to come and sit through a workshop and to learn about the methodology, I think that was a very strong step, understanding the value to utilities within the association, certainly within the state of Iowa. I also want to offer a little bit of why I think that really for this to stick, it needs to be something that is more of a formulated technical assistance program. We had a 3-hour workshop, and I actually procured that workshop. Great interaction. The challenge is, and I mentioned it in that workshop that we did back in November, is we're busy and we're coming back to very busy activities and our business that we've got to attend to. And we also were using some common examples, so we didn't use our data. And Will, I really liked your point of it makes it real when you've got to struggle with that data. And that's what we've seen in a number of state programs as they move forward, where the stick really happens, back to that slide that you had, Will, with the team there, is the interaction back and forth with that data and asking, the questions about our data, especially when, and I've seen it so many times, you bring up the accuracy in the water balance slides and the things that are there that are causing some challenges. When we're wrestling with our data, that's where we really start to move to implementation. We ask questions that we may not have asked before, instead of, as you said, give me that single number. So this is a an interesting opportunity, I think, in Iowa, in that it is coming from a utility side of it, saying this is something that we would like to have, like to explore. A little bit different than some of the other pilots on that state program pilot slide that you showed, Will, of where it actually went from the state out. So this actually is the utilities embracing this best management practice and actually then taking that for funding back to the state as a collective group. So excited about that, at least from a perspective of how to bring some strength to it and to learn more. And then obviously from the customers and your utility operations is the direct benefit to you as a utility. So I wanted to add a couple of those points as they relate to other pilot programs and training programs that are underway. And then would love to see how we can manage this to open up for Q&A, a little bit about program outcomes, what this might look like, give some back and forth, or anything on the technical side if you've run into issues, those that have been performing audits. So Drew, why don't we want to make a general statement that if you're on mute and you know that your system has hold music or anything like that, please stay on mute until you're ready to answer a question on your own mute on your side. Otherwise, go ahead and unmute all the lines, Drew, and then we'll do some Q&A unless you have some in the queue. Do you have any that are in the queue there, Drew, to start with?
No, Steve, we don't have any that have come through the chat box, so I'm going to open all lines now.
All right.
About 600,000.
Okay. And just a reminder, if you can place your line on mute unless you have a question, that would help cut down the background noise.
So, Will, I'm going to toss a question back to you. You mentioned the test and where there was actually an in-field test on the one that was reading 142%. I'd like for you just to take a minute and talk about calibration versus testing. Many folks have been, quote, testing their meters, but maybe just a brief moment about that, if you could.
Sure. So when it comes to supply meters, this is an illustration or a sort of a side view of, this one happens to be an orifice plate meter, but if you have a Venturi style meter, similar deal. This concept applies to any technology of meter, if it's a mechanical meter, positive displacement turbine, any type like that, or even an electronic meter, such as a magneter, ultrasonic. So the meter itself has multiple parts. The primary device within the meter is where the initial measurement happens. So in a Venturi, that's the throat where the difference in pressure upstream and downstream occur. In a mechanical meter, it's the chamber or wherever that mechanical motion occurs. That's where the primary measurement happens. There's also a secondary part of the meter that is the brain of the meter. That motion has to get translated. In the case of a Venturi meter, its difference in pressure then gets converted to the register or the transmitter, or if it's positive, or if it's a mechanical meter, that number of motions or sense of motion gets translated into either pulse. Somehow it gets translated into flow. And that translation happens not in the primary device, but in the secondary device. And then just for conversational purposes, there's also a third device, which can be your SCADA system. So the brain of the meter or the transmitter sending whatever that translation was, sending it to a third location. Maybe that's where it goes to live forever, such as your SCADA system. If you don't have a SCADA system, then it's just the primary and the secondary. So I said all that to articulate the difference between when this method is dealing with testing versus calibration. Testing is looking at the hydraulic piece, the primary device, where that initial measurement occurs. And calibration tends to pertain to the electronics or the signal that's actually coming off of the secondary device. And so it's more of a electronic relationship, looking at, is it programmed correctly? Is it spanned correctly? And if you have a SCADA system, is what's leaving the step 2 showing up the same as there as step 3. They're two distinct activities. They're both important, but they are two distinct activities. So if you're only doing one, you have a limited understanding across the spectrum of, because if there's an issue such as this one here that we saw, that is an issue in the primary device. It's an issue where the primary measurement gets taken. It's not an issue at the secondary device, anything that a calibration would reveal. So both hydraulic testing and calibration are deemed good practices, best practices to do, but just that is something that those terms are kind of interchanged and thrown around, so it's good to distinguish between the two. Happy to hit any follow-up questions if that generated any for any of the listeners.
Good deal, Will. The reason I asked that was because that is something that we hear a lot. Well, I'm testing my meters, and my meters are checking out fine. Many times that's just really assuring that 4 to 20 milliamp signal, but we're not doing a secondary or volumetric type test. So let me go ahead and pause again for questions. If you have questions relative to some of the technical things that were described today, things about a potential pilot, and that's what this is, obviously, is an exploratory conversation with utilities as we are looking at, Steve's looking at pulling together a potential pilot type program, and we can offer at least some feedback from other states. Questions? All right, I'll take a second and maybe buck it back to you for just a moment, Steve, and maybe you can kind of give your perspective of how you might gather some feedback from this webinar, from your members and the folks that have been on today to look at sort of having some educational aspects. I know that one of the things that we are doing is trying to get this information also to DNR and to help them see what other states are doing to have a good gauge and understanding. But anything you want to comment on the feedback loop, Steve Marsh, from this point?
Yeah, I think, first of all, thanks everybody for listening in today. I'm going to send out a follow-up email to everyone that was in attendance today. And from there, hopefully we'll get some response back that you do want to continue with this and possibly be part of a pilot program going forward. So that's the next step. Be looking for an email from me on this.
Very good. And Drew Blackwell, maybe a quick comment about the recording. We did get a recording today. Is that correct?
That's correct, Steve. And we will be able to share that out. We'll send that to Steve Marsh, and he can distribute that out to all the attendees here.
Sounds good. Okay. Well, gang, I'm going to do one more opportunity maybe for open mic for questions regarding any next steps, anything that you learned today, anything that's confusing that we may can offer while we're here. And then I'll push back to you, Will, for kind of a last word and to close this up. So we'll hold it open for just a moment. Any questions for Steve on next steps? Steve Marsh from the group. All right. Will, let me push back to you for kind of a wrap comment on methodology and take us out for the webcast.
Sounds good. Just a big thanks to everybody who's joined today to join our initial conversation about the M36 method. At the end of the day, the goal is identifying what's cost effective, identifying what best serves the utility and the ratepayers and the resource. So hopefully you found something that was helpful today and are excited to continue the conversation from here. So with that, we'll conclude, and I wish everybody a good day.